chemicals in the pump.
All right, it's the 31st of August 2019. The Shark is in the test pool. Power is on, reading 12.51 volts. She's just sitting here. She's drawing about 0.18 amps, just resting. So the receiver is on. The receiver is also telling me that the receiver voltage is the receiver voltage is 5.1 volts, and the external voltage, which is the battery of the Shark, which is not really the Shark's battery, it's a test battery, is also reading 12.6 volts. She's just sitting here. This will be a static test of propulsion, so I can get an understanding of the current draw of the Redmond battery with the Redmond battery with this prop combination and its direct drive. So yes, it is a static test. I'm sure in the real world the numbers, because the model will be moving and not pushing against the test stand, will be lower. So I'll zero out the throttle. Throttle should be 0. And we're going to commence the tests. Okay. Okay, at 50% throttle, we saw a little wake action happen. And let's see. And we have about 12.24 volts. She's drawing 1.13 amps. Okay, 1.13 amps. 50% throttle equates to 74% total throttle from all the way to one end to the other. So that's about right. So this is my normal cruising speed. So normally my cruising speed, I drop to about 12.24 volts and I draw about 1.17 amps. So I have two 7.5 amp hour batteries in parallel, about 15 amp hours power. So all things being equal, I should run about 13, 14 hours all day at this speed. So again, I'm at my normal periscope step speed, just cruising along, drawing 12.24 at 1.15 amps now. Okay, so it's about 100. What am I looking at here? 14 watts. Drawing 14.2 watts of power. Okay, I'm going to bring it up. So at 60%, okay, she's cranking along there. I'm drawing 12.2 volts at 2.1 amps and 25.5 watts. Okay, that is at 60% power, which on my readings of the throttle setting, let's see if I can see this for you guys, it's 80%, but is actually about 60% of the forward throttle. Bring it up to 75. We have dropped down to 11.88 volts, drawing 4.53 amps. She's really churning and burning back there. Okay, so whoa, we're getting eddies and whirl. Now I'm getting a low power. She's dropped to 11.6 volts, and I'm drawing 7.72. And that's, ooh, I cranked it all the way up. 9.3 amps, close to the fuse blowing. At 100% power, she's at 10.6, 106 watts, 11.4. That's at flank. At flank again, it's 11.5 volts, 9.1 amps, 104 watts. So I bring it back down to 50, and let's see how she recovers. I hope I'm probably not recording. Oh yeah, I'm recording. Bring it down to 50, normal cruise speed. She jumped back to 12.3 volts and under an amp, and I'm drawing 12 watts. She's 0.98 amps, 50% throttle, 12.3 volts. I think we're drawing, as you can see, exactly 50% throttle. That's channel number 3. Channel number 3. So when I crank her up, she's going to draw about 9 to no. She's on the verge of tripping the fuse. So definitely, if I know, you know, but if the fuse blows, I definitely know that something proper happened. So this is very cool. Okay. All right, that's it. Again, this is the other screen, which tells throttle is at the 75% mark, which is actually half is off. I have it set that the middle 50% is off, so it's 0 on the other screen. It's because this is made really for drones, so you want to look at it that way. But say we're running 12.2 volts. This says, my meter says 12.32 volts. This is more accurate at 0.98 amps. So I'm very happy. You know, that's, of course, I'm not moving servos. I'm going to do a test afterwards just to see what kind of power I'm drawing. And I'll have the numbers in a chart at the end of the film. So that's it. Thank you for watching.
You're gonna need a bigger boat.